All right, so I think it's working. So we are reviewing for our test tomorrow. And so far, we just did this factoring one where we said to ourselves, hey, x plus 3, let's just call it y for a minute. We can factor like normal. And then once I have it factored, I pop back in place of y, I put in the x plus 3s. And that's all from there. So I got my two answers, easy peasy. And then we are shimmying over to number 6, where we are supposed to convert this from standard form to vertex form. And we were just saying A has to be 1. So if it's not, I have to make it be 1. So I'm going to factor out a 3. Yes, that does mean I'm going to have a fraction here. And so what? And if I remember, I'm going to leave myself a little space on both sides. And the reason why I leave myself a little space is because I'm about to complete the square, but in like that funny way. So I still need half of b squared to find that magic number. So half of 2 is 1, and 1 squared is 1. So the difference between solving by completing the square and just rewriting using completing the square is we're going to leave it all in the same line. And some of you were making this mistake, so please pay attention. So my magic number is 1. I'm going to add 1 right there, but then I subtract 1 right there. I'm going to be smart and write it as 3 over 3. Some of you were adding 1 2 times. You were adding 1 here and you were adding 1 here. You can only, that's when you're doing solving, right? And you add 1 to both sides. I don't have 2 sides here. I'm only working on the right-hand side. So you can't add 2 to one side and nothing to the other, but you can add 1 and subtract 1 in the same line, because that is a net change of 0, right? So I didn't actually do anything, but I've set myself up for the next step. And the next step is that all these first 3 will always be a perfect square trinomial. So if I factor that, factors of 1 that have to be 2 or just 1, 1. So I write it like that. And over here, I'm just going to combine these 2. So it's going to be a positive 2/3. The only thing left to do is distribute that 3 back in. And that's it. There it is. Now we're in vertex form. I can look at this. I know that the vertex has got to be at -1, 2. If it's test day tomorrow and you are blanking on everything, remember that you could just take the original and find the vertex, -b over 2a. Right? So you could go down that road if you are stuck and you don't know what to do. But I mean, once you get the hang of this, it is really fast. All right, next section, we have a bunch of quadratic stuff we're supposed to sketch. Would it be more helpful if I did 7 or 8? Anybody have a preference? I would guess 7, to be honest, but that's up to you. Anybody care either way? No? All right, I'll do 7. So the directions here are, they gave us a quadratic and we have to find all of these things for that quadratic and graph it. Well, lucky for us, we know how to do this, hopefully, right? The vertex, I have a formula, -b over 2a. That's going to get me the x coordinate of the vertex. So let's just pop in those values. -b over 2a would be a -4. Oh, of course, it's an inconvenient number, but whatever. So that's just positive 15/4. And now I just need to find the y coordinate. So I'll take 15/4, plug it back into the original and see what comes out. So I'll do my work over here. -2 times 15/4 squared would be 225 over 16. Plus 15 times 15/4 minus 18. Okay, so that's -450 over 16. This is 225 over 4, but I needed to have common denominators, so I'll multiply it all by 4. So wouldn't that be a positive 900 over 16. And then what's 8? 16, I don't know. 288. All right, so let's just combine those. I'm getting 162 over 16, which is going to reduce down to 81 over 8. All right, so there's my y coordinate. Oh, that one is quite inconvenient. But there you go. To find my zeros, I'm just going to set the whole thing equal to 0 and solve. I'll try and factor and we'll see what happens. So zeros, and have 0 equals negative 2x squared plus 15x minus 18. So if I'm going to factor this, I would need factors of 36 that add to 15. Are there any? 3 and 12, right? Oh, good. So it is factorable. So I'm going to go ahead and factor it. So I do slide and divide. You do you. Divide by whatever you multiplied by in the beginning. So now I have negative 2x minus 3. Oh, you know what? I'm not sure how the negative works. Do you have to factor the negative out in the beginning? Maybe. I'm going to, just because that will make my life so much easier. So if I divided everything by a negative, that would change this to a minus 15. Right, so I'm dividing everybody by negative 1. So that would be positive, yep. So then this would become negative 3 and negative 12. Okay, multiplied now, it would be by a positive 2, right? So I'll have to divide by a positive 2. So 2x minus 3 and x minus 6. So then my answers, my zeros will be 3/2 and 6. Oh. Get this so we can see the whole thing. All right, the y-intercept luckily is super easy because all you have to do is plug in 0 for x, and all I get out is negative 18. Yes. Axis of symmetry is super easy. If you know the vertex, it's just x equals whatever your x coordinate was. So in this case, 15/4. You do need to write x equals though. Domain, that's easy. It's always all reals. Hooray! And then range, y is this graph going to be up like a cup or down like a frown? Down, right? Because A is negative. So I have this down like a frown graph. So my vertex is going to be a maximum point, which means my range would be y is less than or equal to the y coordinate of my vertex, 81/8. And now I should be ready to graph. Let's see. I'm going to start with my zeros actually. 1.5 and 6. My y-intercept is super inconvenient. Let's see, that vertex, if I change it into a decimal, 15/4 is really at 3.75. Which appears to be exactly halfway in between my two x values. So that's a good sign. And what's my y? 81/8 is really 10.125. Oh, that's so annoying. I don't know, so somewhere like here-ish. I guess I could use a scale, but too late now. So my graph would do something like this. My y-intercept makes sense because it is going to hit at some negative value way down there. I just can't see it on my graph. Okay, the ones on your test should fit better. Sorry. If you forget everything, right? If you forget everything on the left, does that mean that you are gonna have a blank graph? No. You can always create a graph, even if you don't remember anything else, because you can plug in 0, plug in 1, plug in 2, plug in 3. Eventually, it's gonna give you a parabola. We also, if this had been a little bit of a nicer, well, why don't we just grab the next one? We don't have to find all the other parts, but let's just talk about, because I want to remind you of that nice little pattern that we have. And this one's very easy to do it with, because if I look at the original, this is the one that you can just look at it and tell me what the vertex is. What is it? My vertex is at -1, -4. So when I go to graph, I can start at -1, -4, which is at a nice point, unlike the last one. And then to get the rest of the graph, do you remember the pattern? You just take a look at what A is. In this case, it's 3, right? So I'll take there's that pattern that it always follows. It just goes up by the odds, 1, 3, 5, 7, blah, 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 if you could. So all I have to do is multiply them all by A. So what is that telling me? That means from that dot, to make my next dot, I'm gonna go up 3/1. So there's 1, and I would mirror it to the other side. To get my next one from the point I was just at, I would go up 9 now, which, yeah, I'm gonna be off my grid, but if I could, 1, 2, 3, 4, 5, 6, 7, 8, 9, that's not so bad, over 1, and then just mirror it over the other side of your axis of symmetry, which, remember, the axis of symmetry just is the vertical line that runs right through the vertex. There it is. So that's the one that we're mirroring against. And there we go. That's enough. If I connect my points. So if I know the pattern that quadratics follow, especially if my vertex point is starting off at a nice point, easy peasy. In the last one, that wasn't so convenient because our vertex was like at this random spot in the middle of nowhere. So it does still follow the pattern. It's just, it's weird now. It's not at nice points. So anyway, there's those. Next up, in the next section, you have to write the equation of the different quadratics. Okay. What should we do? I'm guessing something like 11, probably. Let's take a look at 11. So this one, they give you the 2 zeros and they say, bless you, it's going to pass through this point. So yes, you can use intercept form, but I actually think it's going to be a lot easier if you use that shortcut with the sum and product. So here's how we do it. We're going to start off by finding the sum of my 2 zeros. So if you literally add these 2 numbers together, the √5 just cancel out. And then don't you just have 1 + 1? So the sum is very easy. It's just 2. The product, I'm going to have to multiply those together. So 1 - √5 times 1 + √5. You FOIL that together, it's also going to be very easy because the outside and the inside are always going to cancel. And then the last, that's just -5. So it looks like my product is just -4. Here is what you're putting this into. Y equals A times x² minus the sum times x plus the product. So we just pop those two numbers in. And then I'll just have to solve for A and I'll be done. So first, let me start by plugging in the numbers I just found. X squared minus the sum, so that's minus 2x. Plus the product, so that would be a negative 4. Is everybody okay so far? So anytime I have the two zeros, I can just use this little shortcut. Find the sum, find the product, pop them in. You've got it. Now the only thing left for me to do is figure out what A is. And that's not so bad. That's where this other random point comes into play. All I'm going to do is take that random point and put it in for X and Y, and I can solve for A. So let's try it. Y is a negative 5. A, I don't know, but X is just 0. So it'd be 0 minus 4. So I'd get negative 5 equals negative 4A. So wouldn't A be 5/4? And then I'm super close to the answer because all I have to do is take this and stick it right there. So my final answer would look something like 5/4 times x squared minus 2x minus 4. That's it. I was just gonna, oh yeah. I just wanted to remind you, if I only gave you one of these two zeros, right? Because sometimes they won't give you both. So if they only give you the one, you need to know that anytime a zero has a root on it or an imaginary number, it always comes with its conjugate pair. So if I tell you this is a 0, you automatically know that this is a 0, whether they tell you or not. So now I'd have both. All right. Yep, Kelly. Oh, I'm just adding. So I was lazy and I didn't write it. I added, sorry. 1 minus root 5, my first 0, plus my second 0 is 1 plus root 5. So when I add those two, the root 5s cancel, and then I just have 1 plus 1 is 2. Everybody's all right here? Any other questions? I'll help you get started on 14 maybe, because it looks like that's the only problem like this, and I want to do it all for you. But when you get to 14, that's the one where they give you 3 random points, and they're like, okay, find this quadratic now. That's where you have to do the whole system of a 3-variable system, because I have 3 separate points. So I take each of the 3, 0, 6, 1, 4, and negative 1, 10. Oh, see, I already copied it. That's gotta be really careful, because if you miscopy something, so annoying. Negative 1, 10. There we go. So what am I doing with these? I'm taking the standard form of a quadratic, and I'm going to create equations with these. So for the first one, I'll show you how this sort of works out. So these are all just x's and y's. Y is 6. Oh, this one ends up being really easy because x is 0. So normally I'll just show you what I'll do it with the next one. This just ends up being 0 plus c. So we're starting off already knowing what c is. Anyway, my next one, this is what it would normally look like. Y equals a times x is 1, x squared plus b times x plus c. And then we clean up that equation. So we'd have 4 equals, that whole chunk is just a, right? Plus b plus c. And then the last one, so we'll do that one too. So it's normally 10 equals a times whatever x is squared plus b times x plus c. Oh, that's right, b. So when I clean that up, it looks like 10 equals, that's a positive a minus b plus c. This one, because I had one of them where X was 0, I already have my answer for C. It's just 6, right? So this one ends up being infinitely easier because now in these two, I can just plug in that 6 and I only have a 2 variable system. So, I mean, should we just do this one right now? Then I'll give you another 3 variable one to try on your own. So this particular one, now that I know that C is 6, I'm just gonna pop in. I'll just rewrite it here. I have 4 equals A plus B plus 6. And then couldn't I just minus the 6 over? So I get -2 equals A plus B. There's that one. And then for this one, I'd have 10 equals A minus B plus 6 minus that 6 over, and I'd have 4 equals A minus B. So now I can just take these two equations, put a star next to them, and I can just solve that system. I already have my B's are going to cancel. So if I just rewrite them here so I have a little bit of room. Add those two equations together, I'm going to get 2 equals 2A, B's are gone. So it looks like A is just 1. And the only thing I have left to find is B. So if I just go to one of my start equations, 4 equals A minus B. So that's going to end up being -3. Once I have my 3, my A, my B, and my C, I'm going to plug it all back in. A is 1, so that's just x squared minus 3x, and then C was 6. You can check your answer. Especially, I would check it tomorrow on your test, right? Pop in that first one. If you plug in 0, you should get out 6. All right, that was easy. For the next one, if I plug in 1, I should get out 4. 1 minus 3 plus 6. Is that really 4? It is. So I know that it works with the second point. And then why not? We'll check the third one. If I plug in a -1, I should get out a 10. So that'd be 1 plus 3 plus 6. 10. Yep. So now I know I have the right quadratic. All 3 points work? Wow. There's one and only one quadratic where that will happen. All right, and then the last one, we have a word problem here. I do have another page that'll let you practice some more with the graphing calculator and the word problem stuff. First of all, I don't know if you guys, I would always give you this. I don't know why it's not on here, but G is just the acceleration due to gravity. So when we're in feet, that's just a 16. So this whole thing is going to start off as -16 t squared. So again, normally I'd give you that, plus the initial velocity times t. They told us, if we read, a ball is tossed into the air with an initial velocity of 25. So that goes in as a plus 25t. From a starting height of 4. So I'd have a plus 4 on the end. So that is the equation that we're working with. Does that make sense? You guys are going to need a graphing calculator anyway. So if you want to go grab one right now, and then we could finish up this problem. Okay. All right, so once you get your calculator, see if you remember how to enter in our equation. Can you do this by hand? Of course you can, but why bother? You have a calculator at your disposal. So see if you can get the quadratic in there and see if you can change your window to appropriately see all the pieces you need to see. All right, so I'm just gonna start walking through typing this in. Hopefully everybody remembered to use the negative button that's under the 3 for that -16. X is the button next to the green alpha key, square, blah, 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 so then it's it. So now you can hit graph, who knows what you're gonna see. You might try zoom 0. And that'll at least get it so I can see most of the parts of my parabola. You'll notice I have a lot of extra stuff though. I really only care about quadrant 1. So what I can do is I can go to my window and sort of tweak this. So let's see, on my X direction, yeah, that's fine. I don't need to go out further or less, but I certainly don't need this negative piece over here. So if I just hit window, this is giving me my X scale. It's going from -2 to +4. So I don't know, I didn't need my X's that, I don't know, I could change this to -1. And then that shows me a little less over there because I don't really care about it. All these Y's, I don't care about any of them. So if I go back to hit window, the lowest the Y value is going to is -116. I don't need that far. I don't need any of the negatives. I'll just go to like negative, I don't know, 10. Because I do like to be able to see like where it crosses. This is pretty much fun now. You know what? I might go a little bit higher just so I make sure that I have the whole vertex and I can kind of see everything. So if I hit window, maybe I want my Y values to go a little higher. So then I would just come down to Y max, right? So instead of it being at 49, I don't know, I'll make it 55. And that is great. I can see all the key pieces that I need. I can see the Y-intercept. I can certainly see my vertex. I can see my X-intercept. I know there's another X-intercept over here, but I don't care about that one. So that one's irrelevant to me. But now I have all the pieces that I really need to find. So the first question is, how long is the ball in the air? Where am I going to find that answer? How long is the ball in the air? Where is the answer to that question? Yep. Yes, whatever that value is right there. Because remember, my X's are the time. So if I can find what that time is right there, in other words, that X coordinate, I'll have my answer. The Y, I already know what the Y is. The Y is going to be 0 because that's the height, right? So if it comes back to the ground, I know the Y is 0. I'm really just looking for that X coordinate right there. So how do we find it? Second, and then that calc menu. And what am I actually choosing here? I want to find that 0, so I choose choice 2. Okay, your blinky guy shows up. It says left bound, so you just make sure you're a little bit to the left of that intersection. So I hit enter, and then right, I make sure I'm a little bit to the right of it, and then I hit enter. That's why I like to have a little bit of negative showing, just so I can like move my blinky guy down without going too far off the screen. I should have the 2 black triangles pointing towards each other, and in between them should be that X-intercept. Hit enter one more time. So it looks like 2.5448, blah, 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 blah. So at that time, that's how long this ball is in the air for, 2.54 seconds. Okay, the next question is, how high does the ball go? Where do you find that answer? How high does the ball go? Heller? Yes, and specifically which part of the vertex? The y coordinate of the vertex will tell me how high it goes. The x tells me how long it takes me to get there. All right, so to find vertex, you need to know if the vertex in this case is a max or a min. Which is it? It's a max because it's the highest point I ever get to. So I hit second calc again, and then I'm choosing choice 4 for a maximum. That's why you need to know beforehand, because you got to know, am I picking max or min? In this case, it's a max, choice 4. And then I do the same things. The blinky guy comes up. I'm going to move the blinky guy to make sure he's on the left of where I think the vertex is. He's definitely to the left there. I hit enter. Move him so he's definitely to the right of where I think the vertex is. And I hit enter one more time. And the blinky guy should always pop right to it. And there's your ordered pair. 0.78, comma, 49.765, blah, blah, blah. So remember what we wanted. We wanted the y coordinate of the vertex. So 49.8 if we're going to round to the nearest 10. How high does the ball go? 49.8, we're in feet, right? When does the ball reach its maximum height? Where will I find that answer? Okay. It's just the x coordinate, right? I already have it on my screen. So it took 0.78 seconds to get there. And then the last question, how long does it take for the ball to reach a height of 10 feet on the way up? So remember what's happening. This ball started at a height of 4 feet, right? Oh, wait. I feel like something's wrong. My y-intercept, that's not forward. Is it? No, why is it giving me a y-intercept that's so high?
Did you put plus 40, not plus 4?
Oh my gosh, so all my answers are wrong. Thanks for telling me, class. Jeez. Oh my gosh. All my answers are wrong. I'm so sorry. The way that we found them was right. Are you sitting there like, why are my numbers all wrong?
He is still right.
True. Jeez. Yeah, Keller.
What do we do if we grab this is the string?
Then your window's messed up, or you typed it in incorrectly. Did you change your window?
Yeah, I just.
Then you come up to me and say, Miss Amy, I don't know what's the matter, and I'll fix it for you. Oh my gosh. Oh. Good morning, Miss Amy. Sure. Thanks. Bye. For you. Oh boy. And you think I'm gonna edit this when I upload it to YouTube? No, I'm not. Partly because I don't know how. All right, so now that we have the right equation in, holy smokes, I gotta change my window. So let's see. Let's change that window to, I don't know, 20. All right, that's better. That's better. So now I gotta change my answers. How long is the ball in the air? Again, I'm gonna find that intercept right there. Second, calc. No, 0. Left bound, yeah. Right bound, yeah. So, oh, I'm actually so glad that this happened. Look at my y. Do you see that? It says 1e negative 12. You guys know what that means if that shows up? That is just 0. That's the calculator being weird. So if you ever get one of your order pairs that has an e in it, bye, see you later. It's really the calculator's way of doing scientific notation. So that's 1 times 10 to the negative 12th power. So it's basically 0.0000000001. Right. So anyway, it's basically just 0 if that ever pops up on your calculator. So the real number I want is 1.7. Gosh, let's erase all these wrong answers. 1.7. Okay, how high does the ball go? That's just my vertex. Second calc. Vertex was a maximum, so choice 4. Okay, we hit enter. We hit enter, we hit enter. All right, that's better. So how high does my ball go? 13.8 if we're gonna round to the nearest 10. And when does that happen at 0.78? Oh, that's the same. I guess that makes sense, right? We're just shifting it vertically. Okay, are these answers better? Is that more in line with what you got? Oh. Gosh, all right, sorry about that. Okay, so the last question asks, how long does it take for the ball to reach a height of 10 feet on the way up? All right, well, I started at 4 feet and the highest I ever got was 13.8. So I know it's gonna reach 10 somewhere in here, right? A height of 10. But how do I get the calculator to tell me that? The easiest way is to just draw a horizontal line at 10. And then I can find the intersection. So if I go back to y equals, we just scroll down. And in a new line, we're just going to graph y equals 10. So when I graph this, I now get that horizontal line. So I can literally see the ball is going to start at 4 feet and then it's going to come up. It's going to be 10 feet high right here. And then it'll continue up, reach its maximum height. It'll hit 10 feet again on the way down, but they are specifically only asking for the way up. So all I care about is what the time. So I really want the X coordinate right there. So all I have to do is find the intersection of my two lines that I have now. So if I just hit second calc and then I choose choice 5 for intersect, it'll ask you a series of questions. Hey, is this your first line? Yep. Is that your second line? Yep. And then for a guess, it does matter because remember that there are 2 different answers. So for the guess, you just move the blinky guy closer to the one that you want it to find. Okay, and then when it shows up, you'll see that the blinky guy gets like snapped in place to the one that it found, and it'll give you the ordered pair. And I can clearly see, yep, y is 10, which is what I want. And looks like my time is let's get around to what, 0.3 seconds? And there we have it. Does that make sense? Now that we have the correct equation, I hope I didn't super confuse you there. Sorry. Okay, so as you're scanning through this, I know we didn't do every single problem, obviously. I'm going to give you some time to try it on your own. But are you looking at any and you're like, I would have no idea how to do that one? Can you just scan the ones that we have left and see if there's any that you're like, yeah, no idea there? Or is everybody okay? Yep, Kelly. 13. All right, let's take a look at 13. Oh, this one's interesting. It has an axis of symmetry at x equals -7. The maximum value is 3 and it passes through 0, 0. This is vertex form in disguise. In disguise. So let's talk about it. They gave you the vertex just sneakily. Isn't the axis of symmetry, isn't it always equals whatever the x coordinate of the vertex is? So that means my vertex has got to be at -7 comma something. They also gave you the something right here. It says that the maximum value is 3. So the highest that this thing is ever going to get to is 3. So there's the vertex. They gave you some other random point. Yeah, it's convenient that it's 0, 0, but that still is just an x and a y. What's the vertex? The vertex goes in for what 2 letters? H and K. Don't I have a quiz to get back to you? Or did you already get it back? Because I remember there was a few of you that mixed that up. Where are the, oh, I'm in the extras, not the handbacks. I do, I have, yeah. All right. So once I'm done with this, I'll hand back your quizzes, the little mini quiz from the other day. Because I had a couple of you that on the vertex form, you mixed this up. You called these X and Y and that H and K. You can't do that because that automatically gives you the wrong equation. Vertex is always H, K. What other random point is X and Y? All right, so now if you know vertex form of your quadratic, which hopefully you do, looks like this. A times X minus H squared plus K. I'm just popping in those four numbers. Y is 0. A, I don't know what you are. X is 0. Minus -7 turns into a +7. Plus 3. Some of you are also doing like your order of operations weird right here. So this whole chunk, I kind of handled this as one whole thing. 0 plus 7 is 7. 7 squared is 49. This whole chunk is A times 49. But don't we write it as 49A? Right? You never write the 49 on the other side. I still have a +3 and I still have equals 0 over here. Now I can solve for A. Let's just minus the 3 and divide by 49. Divide by 49. So I'm getting -3/49 for A. Now that I have that, I can write my final equation. Y equals, I just plug in the A, the H, and the K. A is -3/49. X minus -7 and plus K. Once you have your answer, stop and ask yourself, hey, just pretend like you don't know anything from the original question. If you have this and you say to yourself, what's the vertex of this thing? -7, 3. Oh, yeah. Another thing I should be able to check, if I plug in 0 for X, I should get out 0 for Y. Let's see real quick. 7 squared is 49 times -3/49 is -3 plus 3 is 0. Yes. So, yep, I'm pretty sure I got this one right. Is this all right? Any other ones that you're looking at and you're like, yeah, I have no idea? Helen? 12. 1 0 is there and it has a maximum of 4. Okay, well, if they gave me 1 0, they really gave me 2 because it's I got the conjugate pair, right? So I do have both zeros, but I also need some other random point. And they didn't really completely give me the other random point, but they kind of did. It's hidden again. Maximum value of 4. What does that mean? That means for the vertex, they gave you the Y coordinate, but they didn't give you an X coordinate directly. But they did in secret. Can anybody tell me what the X coordinate has got to be? There is enough information there to find it. What must the X coordinate of this vertex be? Anybody know? Anybody want to just guess a random number? I'll tell you if you're right. Nobody wants to guess. It's a nice number. It's a lovely number. I'll give you some hints. It's a perfect square. This particular one just so happens to be a perfect square. It's an even number, yeah. It's 4. Just so happens to be 4. What? How? Doesn't the vertex have to happen halfway in between the 2 zeros? Right? Doesn't it have to? So if I know my 2 x-intercepts, the vertex, the x coordinate has to be halfway between them. So if I just add these 2 numbers together, and divide by 2. That tells me where the x coordinate of the vertex is. So anyway, now I have all my pieces. So let's do the sum and product thing real quick. So if I add these two together, then the root 3's are just going to cancel. So I'll get 8. The product, so we're going to FOIL these two numbers together. So it'll be a 16 plus minus cancels, and then it'll be a -3, right? So my product is 13. So when I plug in all the pieces, y equals a times x squared minus the sum plus the product. And now let's just plug, I know this is the vertex, but I'm just going to use it as an x and a y. So y is 4, I don't know what a is, x is also 4. Oh, I already squared it. So -3. So -4/3. And then I just write it nice and neat with all my pieces. Ta-da! How's that? Everybody's all right? Yep. 9. Okay, 9. All right, this one, they gave you the vertex, they gave you some other random point. Most important thing for you to remember, the vertex is HK. The other random point is XY. You're going to plug that into your vertex formula. There's the vertex formula. Let's pop in the pieces. 3, I don't know what A is. X is 2 minus 4, close it, square it. K is a -1. Make sure you evaluate this correctly. You're going to handle this whole chunk first. So that's -2 squared is 4. So this is really 3 equals 4A minus 1. That's how we write it. We don't write it as A times 4. And then I just solve. Add the 1 to the other side. Looks like in this case, A is just 1. Once I know what A is, I can write my whole equation. Y equals A is just 1, so I don't need to write it. X minus 4, could square it, plus K. There's. Does that thing have a vertex of 4, -1? Yep. Does it go through the point 2, 3? I don't know. Let's plug in 2 and let's see if we get out 3. If I plug in a 2, yeah, I get out 3. Yes. Yeah. Sure. So number 2 is factoring, but I have that weird quadratic pattern. But the only thing I have to do differently is instead of my first thingies just being an x, I'm going to make them x squared. So are there factors of -36 that add up to be a -5? I hope so. Are there? Ooh, do I not have any? It's gotta be. Are there? What? Oh, yeah. Just checking, right? Oh my God, the internet's gonna judge so hard. Whatever. All right, so any users. So the only difference, normally it would just be an x minus 9 and an x plus 4, right? But these were x to the 4th and x squared. So these become x squared minus 9, x squared plus 4. That's the only difference. Now I notice, ooh, look at this one. That is the difference of 2 perfect squares. So that one will split again, x plus 3, x minus 3. This one does not split. That is not the difference of 2 perfect squares, right? It's the sum. So that one doesn't factor any further. So now to get my answers, I have 2 of them real easy. I get a -3, I get a +3. This thing, x squared plus 4 equals 0. Let's just solve it. You're going to have x squared equals -4. I'm going to have imaginary numbers over here. That's all right. So I'm gonna get positive, negative. What is the square root of -4? How do we write that with imaginary numbers? Yep. Oh, you're so close. Wouldn't it be 2i? Yeah, because you want to do square root of the 4. So that's just going to turn into a 2i. So there's my other two answers, positive, negative 2i. I should have 4 answers because my degree was 4, and I do. So hooray. But that's the only difference. If it has that quadratic pattern, you would put 2s instead of 1. All right, everybody's okay here? So one thing that I did want to show you, because I keep seeing people making this mistake. When you are, I want to show you the difference. I think it was, what were you guys doing it on? Was it this? Oh, now I'm blanking like why you were making this mistake, but I want to talk about it anyway. So I don't know how to, can I screen share something else? Stop share. And then we'll do a new share to this share. I don't know if this is showing up on the video or not, but anyway, this is what I wanted to show you guys. If you have, let's just take some random quadratic, like, I don't know, x squared plus 3x plus 2. I want to change some things about this. Let me change the window here. And let's drop this one down a little bit. Let's do like a minus. All right, that's good. So I think it was, were you finding the, maybe you were finding the vertex or something. But let me just stick this in here. If you had 2x squared plus 6x minus 4. Yeah, I think this was it. So if I gave you an equation like this second one, y equals 2x squared plus 6x minus 4, and I said, hey guys, find me the vertex of this. I saw some of you were like, oh, let me divide everything by 2, and I'll find the vertex that way because my numbers will be nicer and smaller. But look at, is the vertex the same? No, now it's completely different, right? So you can't do that. You can't just take a quadratic and like change something about it and then expect the graph to stay the same, because it doesn't. What does stay the same are the x-intercepts. That's why you can do that when you are solving a quadratic. You could divide both sides by 2 or whatever you wanted. But if you are trying to find parts of that parabola, you've now changed it completely. Does that make sense? So the only thing that you could do is find the x-intercepts, leaving it as it was. Otherwise, you really have to deal with the quadratic that you're given because the vertex is going to change. Anyway, all right. Anybody have any questions right now? You all right? Okay, so let me stop this video because I think we're done. Sure.